our ships not only go and survey, they help whenever there's a crisis or need. So they're not just hydrographic. Things that you would think the Navy would do, we do as well. This was also, on the right, was a case where we have a glider operations center that controls gliders. We have periodically we have fail rates with our gliders. This is one of them that they couldn't control anymore. We knew someone was going to have to go get it. So we would do drift forecast every day so they would have an idea where to send the boat to find it. Because they're about that big and they're a big ocean. And all you can usually see is the tail fin. Some other support products that we've done, we helped with Fukushima, trying to decide where debris was going, where the nuclear material was potentially going to leak to. So we did some material surfaces. So I say if we lost something in this area, where it was going to go to. You can see here it's going to pick up along fronts and strong temperature gradients. So this helped guide in looking for some of the debris and some of the things that were lost. So pretty much any humanitarian type incident that happens, I usually tell people if it involves the Navy and it makes CNN, it will come across my desk. And that has proved to be true more times than not. And this is a similar thing looking at drifts. We've been looking at a lot more drifter support recently because ocean models don't do Lagrangian drift terribly well, mostly because the drifters are actually seeing physics that the models can't reproduce. So we had this case where we had a drifter, and it's kind of hard to see. It started here, it came up, crossed the edge of the loop eddy, and went into the Gulf of Mexico. So we're trying to see how many particles we have to put in the water to replicate that movement. And so we started off with a little 10 kilometer by 10 kilometer box, and then up to a 20 kilometer, and all the way up to a 70 kilometer. We had to put in a 70 kilometer by 70 kilometer patch of drifters before we could replicate the Lagrangian drifter. So it tells you there's how much variability, and so even, you notice when we did the drift products for the gliders or for looking for the debris from the airplanes, we put a big grid down on where they say their single point is, because we know there's going to be variability in the model. We need more than one data point to actually get any accuracy when you're doing hindcast or even forecast. And that is all I have. Now, one thing I realized when I got through, I forgot to say, I said I was going to go back to COAMPS. COAMPS is a fully coupled model, and that is our actually next generation of regional model. We are in the process of moving to coupled systems at NAVO. This year we are moving toward an ocean wave coupled model. Next year we will have a full COAMPS system, which will be ocean, wave, and atmosphere coupled system. So we're in the process of going to coupled ocean modeling, and all the challenges that brings that we don't quite know about yet. That'll be an interesting process. So that's all. Let's do some questions.
Given that your customer is primarily the Navy and I guess for acoustic, anti-submarine acoustic properties, the question occurred to me when you were discussing the difference between the model and I guess the actual observations for internal waves. How much of a difference does that offset have in the Navy's interpretation of the accuracy of their ability to place anything?
They're still working on that. For them, internal waves is still a very new concept. Even oceanographers have known them forever. The Navy's still trying to get a grasp on that. Unfortunately, it does affect the acoustics a lot, and we're still trying to convince them of the time scales. There are places where the internal waves go through. What they're mostly worried about is, in their effect, the acoustics has a very similar function as mixed layer depth, but they call it something different when you move into sound speed space, but in fact a mixed layer depth. And when you have these internal waves coming through, you can go from, in some places, having a 200-foot mixed layer depth to no mixed layer. And so getting them to realize that on timescales of even an hour, that can actually change your acoustic propagation, that has been more of the challenge than anything, just convincing them that the ocean is actually moving and not stagnant acoustically. You had a question?
So, what was the reason for going to Delft 3D several years ago
For the high resolution regional models? A lot of that came on mostly by support. They were giving us the support that we needed. It's helped they've gone open source now. It's not, we don't just have to purchase it. We did work with them at the time we were giving them money, and they put some things in it specifically that we asked for. They were willing to work with us. So I'm not sure all the details because most of that discussion actually happened before I got there.
I don't know how much free time or how many bids you guys have every day, but is there any pressure to publish in regular journals, or do people do that for fun?
People have no time for that. What we do is very funny because we're called an operational center, which technically means we do operations and we do not do research. But you can see from what we do research, but we don't do it in, I have 6 months to analyze this and then I'm going to write a paper. You analyze it today and you write it today and you move to the next project. And people do have a lot of expertise. Usually I encourage my people to go to like an ocean science conference or an AGU to actually present posters. That's the closest we actually get to anything where we actually publish. But you don't have time. I'm in the process of rewriting a Navy document, and I've been working on it for 4 years now. And I'm not done because if I get an hour a week, it has been a good week. So yeah, we just don't have time for things that take that much time and thought process to actually accurately write a research document.
So is y'all's office for pretty much all Navy bids ever that has to do anything with oceans, or are there like multiple offices that kind of have like different sections of the world?
Navy-wide, we are the go-to places. The Navy has really tried to cull a lot of that with the Reach Back Center. So they're saying the area of expertise for oceanography is the Naval Oceanographic Office. And in Alma said Naval Research Lab, there are sister agencies, so anything that needs development goes through them and then transitions to us. But we work very closely with the research labs as well.
I had a couple questions.
Okay.
One was, NAVO, when they do their mapping expeditions, routinely measure the sound velocities in the locations they're in.
Mm-hmm.
Do they collect CTDs, or they use the sound velocity meters, or they use?
Okay, so that's kind of, we've changed. It used to be a CTD. The NAVO ships now have what's called a moving vessel profiler, which is a little sled that they push off the back of the ship, and as they go, it goes down and comes back up, and so it continuously takes profiles for as long as they want to. So they can send it down and take one, or they can just let it go up and down as long as they want.
Doing this TOYO, are they collecting temperature as well as?
Temperature and salinity is what it measures.
So do they share those data with you? Because I would think with all the surveys they're doing, that would be good ground truth for your models.
We actually get those data real time.
You do? Oh, that's great. So you do have some validation from them.
Mm-hmm.
Yeah.
Mm-hmm. Yeah, that's the one great thing. The technology the past few years has allowed us to start getting all our ship data real time instead of waiting for it to be processed.
So do you provide them a 3D model of the sound velocity in the area they're working in based on your models that you have?
They have a little more difficulty getting that large bandwidth back to them. Usually what we do is we give them a pre-planning package so they have an idea of what they should see before they get there.
Cool.
So you mentioned going through how useful the profiles were for you in particular,
Mm-hmm.
check and understand. If there are observations that are particularly good for you to have,
Mm-hmm.
is there any feedback to the Navy to help support those kind of observations?
We do what are called water sampling plans. We don't always get the data that we request, but we do put it out there saying this area the model has not gotten fed in a long time. We really need data here. The thing about the Navy is they only collect data where they're going. They will not go out of their way to collect data because that's lots of money for fuel and usually time out of what their focus is. So they do give us a good bit of data where they are, but it's usually very hard for us to get data where we want because that's not.
More like if the Argo floats, for example,
Mm-hmm.
That's the most number of floats
Mm-hmm.
and profiles that you're going to get. If it were proven to be very useful for your modeling, would the Navy then support the Argo system?
We already support the Argo system.
Is that the kind of thing that gets fed back based on the impact on the model of the observations, or?
Yeah, actually, majority of the data, I think all the data that was shown there were Argo data for the profiles. Yes, with the gliders, we're given a little more opportunity to say where we need data and where we want it taken. Argo, we pretty much collect the data through Argo and we share our data with them through data exchange agreements, but we don't necessarily work with the Argo program to say, will you please put profiles in here. That's one reason why I said I like the ship of opportunity, because a lot of the places that we're interested in, cargo carriers go as well. And so we get a lot of data that way that really help feed the models.
So are there cruise ships that the University of Miami students go on across the Atlantic back and forth making measurements as well? Are you familiar with those?
No, I'm not familiar with those. I don't know. A lot of universities do not send us data unless they're in with Argo as well. We have worked with certain ones. Scripps is now a little bit better about giving us data. University of Washington works a little bit better with us getting data. Rutgers, we get their glider data. But we usually have to reach out. Getting data back to NAVO is very easy. It is literally sending an email. And so it is not a difficult thing to do, but it's actually finding the people who are taking data where we want it and then knowing they're taking it, which is usually the hard part, and then getting it back to NAVO. It's usually a fairly simple thing once we get the process in place.
So how accessible is NAVO data?
Like I said, most of the data that is available, it has been collected through public sources. NAVO's CTD data is not publicly releasable. The Navy data is, you can just forget that one. So pretty much NAVO data is fairly off limits unless you're on a DoD contract.
So as a follow-up question, climatologies are always of great value, and you appear to be updating your climatologies on a regular basis. Are the climatologies available?
The climatologies are owned by NRL, and I think they are available through NRL. Okay.
How much cross-talk do you get with NOAA?
I would be very careful. Dr. Weisberg and I had this conversation yesterday. NOAA and the Navy, in theory, should play very nicely together, but that has a tendency not to happen probably the way it should. NAVO actually provides their global ocean model is actually, we provide them boundary conditions to restart their model every day. So their model is dependent on our model because NOAA doesn't get the data sources we do, so they can't do the data assimilation. The NOAA buoys, which are all publicly available, any of y'all can go get stuff on NOAA buoys. They do send us the data as well. We get their data. Again, the Navy data doesn't go to anywhere. But I would say they're probably not as fluid as they should be since they're both government agencies, but I think that gets a little bit into the food fight over funding. Everybody has certain mandates. They try to fall under those mandates, and they don't deviate from them too much. So, but even when you get into the modeling, the future modeling developments are full Earth system prediction systems. So HICOM and NavGem and COAMPS and the INCOMs will become part of a full global system, including ICE and Riverine, and I don't even remember what all else. There's a big consortium. Navy is in with NOAA, which is also in with several other groups that are actually doing large-scale modeling for the development of these full system predictions. Of course, those are down the road. It's more like 2020 before any of that will actually come online, but they are working together in that realm fairly well.
How is Naval sent the data, like from NOAA, for example? Is it like satellite broadcasted to you guys, or just like through the internet?
It's through the internet. Yes?
So you're looking at the predictions. How much feedback do you get after the predictions are out as to their accuracy? Especially if it's a non-traditional source, like I mentioned, there's a lot of Navy research that would want to know what a vertical profile are. Let's say somebody's doing LiDAR, which gives you vertical profile. Do
Yeah.
you get any feedback back? With how you're doing?
We do with some customers, and some customers we don't. We usually go on the assumption that no news is good news. That's usually the way it works. Usually if the model is giving a very bad forecast, they are not afraid to tell us that it's giving a very bad forecast. That's actually one thing with our Sulu model that we had set up. We knew that our regional model had issues in the small straits as you go into the Sulu. We knew that the bathy was wrong. We knew. And about 2 weeks before we went operational with the Sulu model, we had a Navy customer call us up and go, usually your model's great here, but yeah, not so much last time we went through. And so we actually went through and compared our regional model to our higher resolution Sulu nest, found out the Sulu was spot on from what they were reporting. So we were very excited when we actually got to go operational with that model because we had already had data. The customer actually said, this is what we saw, and we're able to validate it against Navy observations, which do not happen very often. Like I said, usually it's just when something goes bad.
The errors don't lead to any kind of running aground or collisions, do they?
Thankfully, none of those problems have been on us. The past two have been because the charts were wrong. So we can say at least they can't throw that one back in our lap. So far, the ocean currents that we've been supplying have been beneficial to the Navy and not a detriment.
Okay, well, thank you very much.
Thank y'all.